the previous lecture, we looked at the pre-Socratic philosophers and analyzed some of their thoughts. We saw that they raised various, what we might call scientific issues. For example, what is the world made of? How did it come to be? They also raised methodological issues. How far do we trust our senses? How much of our study of the universe has to be based upon logic and reason, and how much upon observation and sense perception? One of the things perhaps we didn't notice about the pre-Socratics is that all of them lived in the outer colonies of Greece. That is, either in Asia Minor, now Turkey, in Sicily, or in southern Italy. They lived there in the 6th and 5th centuries BC. Only one of them, that is Anaxagoras, actually was ever in Athens. And Athens is going to be the center of our story for the next 4 lectures, because now we're going to go to this new cultural center of the Greek world, Athens, and look at Plato and his student Aristotle. In this lecture, we're going to look at Plato's general ideas, not so much his specific ones on natural philosophy yet, but his general ideas in the background of his thought. Well, Plato, I think, needs no introduction. All we need to say is what one wag remarked, that all of philosophy is just a set of footnotes to Plato. Well, be that as it may, what about Plato's influence for the history of science itself? Well, in fact, I think there are 4 ways in which Plato's thinking impacted the history of science. Let's put this in context, though. We don't want to say that Plato was primarily a natural philosopher. We'll talk about that more in the next lecture. But remember that Plato's works, written mostly in dialogue format, touch on ethics and politics, living the good life, and that sort of thing. But these 4 ways in which he impacted natural philosophy, maybe sometimes without intending to, are as follows. 1, his ontological view. What do we mean by that? Ontology is the study of being. What exists, how it exists, why it exists, the study of what being is. The second one is his epistemology. What is epistemology? It's the study of knowledge. It comes from the Greek word episteme, which means knowledge. What do we know? What is knowable to us? How do we know what we know? The third is Plato's interesting emphasis on the mathematical basis of nature. In fact, most of the second half of this lecture is going to be talking about where he got that mathematical view from. The fourth point, which we're not going to talk about in this lecture, it's the entire next lecture will be about this, and that is the natural philosophy, the expressly natural philosophical content of one of his dialogues entitled The Timaeus. All right, well, let's then spend this lecture going through the first 3 points: ontology, epistemology, mathematization of the world. The basic thing that you need to know about Plato is his theory of the forms. Now, much ink has been spilt trying to understand the theory of the forms and interpreting it. So we're going to do the quick and easy introduction to the forms. According to Plato, the forms are the eternal, unchanging exemplars of things that we see in the natural world. Let's take an example. Trees. We walk outside, we see lots and lots of trees, lots of individuals. What Plato would say is that there is an ultimate reality of tree that exists, truly exists, outside of the physical world. That there is a form of tree, the perfect tree. All the trees that we actually see are imperfect representations of that perfect form of tree. What's important to realize is that these are not just ideas. We call them the forms or the ideas, but they're not mental ideas. They're not in here, they're out there. Those forms are out there. Now, with an idea like the forms, Plato creates an ontological hierarchy, that is a hierarchy of being. The lowest level are our phantasms or imaginings or dreams or memories of things. So that is, for example, a tree that you played in when you were a child that's been cut down. We remember that tree, but that memory's at the lowest level. The next one are then the things themselves. We go outside and we can knock on a tree, right? And that's another level of being, a higher level. Still higher are our conceptions, our abstractions, mathematical if possible, of trees. And at the highest level, in a realm that is directly inaccessible to us, is the form of tree. And that is the true bit of knowledge. That is the true being there in the forms. Now, this view is very elegantly summed up in Plato's parable of the cave, which some of you may already be familiar with. It occurs in Book 7 of Plato's Republic, the Republic being a dialogue that talks about the ideal state and the education of its citizens and its leaders. Parable of the cave goes something like this. There are prisoners, Plato says, in a cave. They sit with their necks chained to a rock, their arms chained to the rock, their legs chained to the rock. This rock faces the back of the cave. They are chained in such a way that they cannot turn their heads, raise their arms, or get up. Behind them, out of their view, towards the mouth of the cave, there's a low wall, and behind the wall there are people walking back and forth, carrying things over their heads, carrying statues of animals and things that are in the natural world. Okay? At the mouth of the cave there's a fire burning. Okay? So the light from the fire shines on these sort of puppets, these statues of things that the people are carrying back and forth behind the wall, and casts a shadow on the back wall of the cave. The prisoners see only those shadows moving back and forth, and since they've been there since the moment they were born, chained to the rock, that's all they have ever seen. And they believe that that is all there is. Well, Plato asks us, well, what happens if we go and we release one of these people? Well, that sounds like a good idea because they sound like very strange kinds of prisoners, don't they? But Plato, using the guise of Socrates, says, yes, they are strange indeed, but how much like us? So that means when we go and we release one of these prisoners, he gets up and stretches, he turns around and he sees the puppets of things being carried back and forth across the wall, and he realizes that the things that he thought were real all the time are nothing but shadows. If he's more courageous, he goes, he climbs over the wall, he passes over the people beyond the fire, he goes out into the light, and he's totally dazzled by the brilliance of the sun, something he never imagined to exist. And what he finds is that all those statues and such like that he saw only the shadows of a few moments ago are actually themselves not real. They're representations of things that are outside. So this expresses what Plato means. The things that are outside in the natural world are the forms. We can't get to them because we're chained as souls imprisoned in bodies that cannot have direct knowledge of those forms. All we see are those flickering shadows on the cave wall, and somehow we think they're real. The question is, how do we become a liberated prisoner? We become a liberated prisoner through the exercise of reason and philosophy, extrapolating from the shadows back to the figures that cast them and then to the real world. Well, if we've never seen the real world, how can we extrapolate? Well, we can't, says Plato. He has a theory that I can't go into very much called reminiscence, which says that all of us, before we were born, lived in the realm of the forms. And so part of the process is recalling what we saw before. This is actually where the word education comes from, you see. It's from the Latin word educere, which means to coax out. And there's a wonderful Platonic dialogue where Socrates takes a slave boy and proves that he actually knows the Pythagorean theorem without being aware of it, because he remembers it from seeing it before he was born. Well, these forms come with epistemological consequences as well as ontological ones. The ontological question is that Ultimate reality is in the realm of the forms. What we're seeing are just dim shadows of the real things. The epistemological consequence is that if the forms have the real reality, then knowledge of the forms is the real knowledge. That's what we're trying to get at, knowledge of the forms. We escape the delusion of sense perception, we escape the cave, in other words, through the exercise of our reason, through the exercise of philosophy, and it's a long and very difficult struggle to do that. Well, unlike Parmenides, who totally rejected sense perception, who rejected the change in the world as illusion, Plato does not. For him, observation is a wholesome activity, as long as it's enlightened by reason, more like Heraclitus's view in a sense. He says, in fact, in one place in the Timaeus, that vision and the senses are one of the greatest gifts that human beings have, because it allows us to experience the world, and by looking at the things in the world through the senses, we can rise by contemplation to knowledge of the forms. Well, in terms of the history of science, Plato's insistence on the ontological and the epistemological superiority of the forms urges the Platonist to move from particular observable phenomena or observable objects to universals. That is, to frame universalized conceptions of the world from individual objects. Now, this is, in effect, I think, a hallmark of scientific inquiry, the discovery of regularities, of patterns, of generalized principles from a collection of individual objects and individual observations. Well, so much for Plato's ontology and epistemology that is grounded in his doctrine of the forms, or ideas. Now let's move on to the mathematical content of Plato's work. Well, it's fairly clear that Plato's emphasis on mathematics and some other aspects of his ideas come from his association with another group of pre-Socratics that we haven't talked about yet. And these are the Pythagoreans. Now, the Pythagoreans are a bit mysterious, and there are good reasons for that. Let's talk about the founding of their school first. It was founded by Pythagoras, supposedly born about 580 BC, but it's almost impossible to separate fact from fiction when it comes to Pythagoras. We have no writings of his. We have no writings by people who knew him. Most of what we have is a tradition that was put together by the members of his school 100, 200 years after the time of Pythagoras himself. So it's difficult to figure out what Pythagoras actually had to say. Part of the story is this, that Pythagoras, who's a contemporary of Thales of Miletus, just so that you can put him in context, he was born on the island of Samos. He traveled in his youth through Egypt, and there in Egypt he learned mathematics and astronomy. This is a refrain we hear again and again from the early Greeks, the importance of the Egyptian knowledge to their own knowledge. Right? We've noted that Egyptian and Greek thought is very different, but it's almost a refrain with the biographies of these early characters that they took some of their knowledge from the Egyptians. When he returned to Samos, it was the time that a dictator, a tyrant, was taking hold there by the name of Polycrates. And so Pythagoras fled to one of the western colonies, to Sicily, to the Greek colony of Croton, which is where he set up his school. Now, what was the Pythagorean school like? Well, first of all, it was based on simple communal living. It was based on shared rituals, and it was based on secrecy. At one time, we learn that there were as many as 300 young men living communally in the Pythagorean school in Sicily, or in the south of Italy. Interestingly enough, by the way, I notice I said 300 young men. It is noteworthy that Pythagoras is reputed to have taught women as well, in separate classes, so to speak, but to have taught women as well, which is fairly unusual in the ancient world. Well, Pythagoras, I think you've all heard of. He's famous for his theorem about right triangles, but we have to fit this in the context and the goals of his school. It is true that someone in the Pythagorean school fairly early, whether it was Pythagoras himself or not, worked out a proof for the Pythagorean theorem, namely that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the two other sides. Well, were the Pythagoreans the first ever to realize this? Well, apparently not. The Babylonians had tables of what we now call perfect triangles. That is, right triangles where the lengths of the sides were integers. So the most common example is the 3, 4, 5 triangle. The Egyptians, too, had lists of these perfect triangles. But it doesn't seem they ever worked out a generalized theorem of how to discover them or a proof that it was always true about the length of the hypotenuse relative to the length of the other two sides. Presumably, the Babylonians and the Egyptians used them in surveying and laying out ground plans for buildings. What else did the Pythagoreans have? Well, their greatest secret was that of what was called incommensurables. What on earth is an incommensurable? Well, what we would call an irrational number. We know, for example, pi is the most common irrational number that we know of. What we say is there are no two integers whose ratio equals the number pi, that is, the proportion between the diameter and the circumference of a circle. For the Pythagoreans, the irrational number they were most interested in is what we call, emphasis on that, what we call root 2. They knew that a square of side 1 would have a hypotenuse that could not be expressed by the ratio of any two numbers. Okay? And this was a great secret to them. According to some of the mythology, one of their number, called Hippasus, revealed the secret that there were such things as these irrational, incommensurable numbers, and as a result, he was drowned by the vengeance of the gods. He was killed. The Pythagoreans were also impressed by the existence of mathematical ratios in music. Again, the mythology, the story is that Pythagoras was walking through town one day next to a blacksmith, a harmonious blacksmith, and he heard that hammers of different weights, when they hit the anvils, gave off different pitches. Well, apparently, according to the story, this made him think about the relationship between the weight of the hammer and the pitch. And he started investigating other sound-producing devices, jugs of water filled with different amounts of water, and striking them and you get a different tone. Maybe after dinner, during a boring after-dinner conversation, you've played this game yourself at the dinner table, tapping the glasses with your fork to get the different sounds. He also did, apparently, experiments, so to speak, with flutes of different lengths and different bores to get the different tones out of them. Most importantly was the work of the Pythagoreans on the monochord, that is, a one-stringed instrument, so to speak, a single gut string of different lengths, and they studied the pitch versus the length of the string, or the weight that was stretching the string. They also developed the notion of the music of the spheres, that is, the heavenly bodies, as they move, make a sound, a perfectly harmonious sound. But wait a minute, do you hear it? I don't hear any music of the spheres. The argument is that we've heard it since the moment we were born, and so we're not aware of it anymore. It's there, but we just don't hear it. Well, the Pythagoreans' emphasis on number arose from their commitment to the idea that the world was number. What exactly does that mean? It seems to mean that the principles of mathematics, the principles of geometry, numbers, ratios, proportions, are the principles of nature. It's the way the world is put together, and in fact, it's more than that. Number is the basis of what is in the world. Now, we have to step back for a moment. We don't want to go away with the mistaken impression that the Pythagorean school was some kind of mathematician's think tank. It was nothing like that. It was a primarily religious, ethical community that promoted ways of living the good, the harmonious, the right life. Among their beliefs, they maintained, for example, the immortality of the soul. They also believed in the transmigration of souls, that souls of the dead take another form. There's one story told about Pythagoras, that he was walking down the street one day, and he heard a puppy being beaten, and he called out to the man to stop beating the puppy because as soon as he heard it yelp, he knew it was an old friend of his. They also showed an interest in number mysticism. For example, the number 4 somehow symbolized justice. They had something called the tetrachus, which was a row of 4 hash marks, essentially, 1, 2 beneath it, 3 beneath that, 4 beneath that, which somehow represented the totality of the universe and of existence. 10 was a number that had great importance to the Pythagoreans. First of all, because it's a sum of its factors, so it seems to be a complete number. Okay. So 10 expresses completeness. The sum of the first 4 numbers gives 10. We take 1, 2, 3, and 4, add them up, and we get 10. Their prime objective was to discover and to live the good life, that is, one in harmony with the cosmos, which would bring advancement to their immortal souls. Mathematics was thus a key to understanding the harmony of the cosmos. It was understanding not only the harmony of the cosmos, but the harmony of life, just like in music, harmony in life. Both of them are based in mathematical proportionalities. Point for the history of science is this. Regardless of why they did this, whether it was for religious and ethical reasons or for mathematical reasons, we want to keep in mind the real reasons they did it, and that was for religious and philosophical reasons. But they brought up a particular question that's of great importance to modern science, and that is, to what extent is the natural world expressible in mathematical terms? How good a language is mathematics for describing the world? Well, look in physics today. Things like free fall motion are expressed in mathematical equations. Moreover, what we can do is we can take an equation, a mathematical expression out of physics, plug some numbers in it and do some mathematical manipulations with it, and we get predictions about the natural world. Right? If we have a cannon, we're trying to besiege a city. This is a classical Renaissance problem that uses mathematics. We have a cannon, and we're trying to besiege a city. We want to know where the cannonball is going to fall. Well, nowadays we have formulas to know at what angle to raise or lower the gun, and as long as we know the force of the impulse behind it, we can calculate how far the ball will fall, how high up in its motion it will go, following a parabolic pathway, and we can aim our cannon shot just the way we want it to. Mentioned the Renaissance a moment ago. Remember the Pythagoreans not only for the next lecture, which is about Platonic Pythagoreanism, but also quite a number of lectures further on, because Pythagorean ideas and ideals were revived in the Renaissance. And there they had an enormous impact. The Pythagorean commitment to mathematizing nature meant that the Renaissance readers of Pythagorean ideas tried to think about how to mathematize nature. I'll only give you one example of a person of the time, and that is Johannes Kepler, right? The astronomer and mathematician. He was absolutely convinced of the truth that the universe was mathematical and harmonious. Why? Well, because God had created it that way, according, as the Psalm says, according to number, weight, and measure. God created the world in number, weight, and measure. And so Kepler, using Pythagorean ideas, started looking for regularities of a mathematical nature in the cosmos. What happened? Well, he found among the many laws he discovered, many of these don't have any meaning to us today because our ideas of what's important have changed. But among the 3 that were important were his 3 laws of planetary motion, about the period of planetary motion, about planets traveling in ellipses, and so forth. All right. Well, these Pythagoreans, with their mathematical view of the world, their mathematical key to the harmony of life, their mathematical interest in music and in communal life, had a great amount of impact on Plato. We know that he visited Pythagoreans in Tarentum in southern Italy. One of the reasons he may have been so impressed by them was that they seemed to live a communal life in harmony. This is what Plato was really all about. His Republic, one of the most important of his dialogues, is how to regulate the proper state, how to regulate the individual within the state, how to regulate the state as a society in a communal way. A lot of those ideas he probably did get from the Pythagoreans. Their ability to create a communal society, which is something that Plato never managed to do and was a great disappointment to him throughout his life, probably impressed him. Now, Plato's dialogues show a large number of resonances with Pythagorean ideals. Plato has the immortality of the soul. We are all souls trapped in bodies. The soul survives death. It goes someplace where it sits around and waits, the realm of the forms, until it is reborn into another body. Right? Whether that's another human or an animal body is up for grabs, right? Depending upon the state of the soul. Moreover, the Platonic dialogues show a great interest in mathematics and in harmony, in proportion. We're going to see this in a great deal of detail in the Timaeus. Now, the Timaeus is the dialogue of Plato's that we're going to pay the most attention to. Very few of Plato's dialogues have anything to do with natural philosophy directly, but the Timaeus does. It's about the creation of the world. Rather curious thing. The Timaeus turns out to be Plato's most influential writing in the history of science. Why? Well, actually, it's a bit of a fluke. Nowadays, I don't think there would be very many people, except historians of science, of course, who would say that the Timaeus is Plato's most important work. Probably not even in the top 5 for most philosophers or students of Plato. But it did have one thing going for it that none of the other dialogues did. And this is where chance, which often plays a big role in the history of science, took over. The Timaeus was the only work by Plato that was known to the West, to Europe, throughout the Middle Ages. There was no other work of Plato. If someone told you, go read some Plato, here such and so is what Plato thought, you would be referring to the Timaeus. It was the only one known. Why? Well, it so happened that in the 4th century AD, a certain character by the name of Chalcidius translated the Timaeus into Latin. Right? If he hadn't done that, there would have been none of Plato known. This Latin translation of the Timaeus, which by the way is unfinished, it's not even the whole thing, it's only part of it, was the only bit out of Plato's opus that was known to the Middle Ages. Fine. Well, there's a lot to say about the Timaeus because it was deeply influential for 1,000 years or more of Western history of science. And that's what we're going to talk about next time, the Timaeus, the way Plato portrays the creation of the world and the Pythagorean mathematical elements in it, and the ways in which it influenced the subsequent development of the history of science.